Okay, folks, welcome to week 3. I love this week. We're going to take a break from the teacher.desmos.com and we're going to just play around with the graphing capabilities because you can just see some absolutely beautiful math that comes out of this. And it's just cool to see all the stuff that you can do. As a teacher, you're going to want to throw up a graph. So here's just a couple of tips. So I can plot a point in each quadrant and turn on their labels. What I'm going to do is read to you each of the 13 steps in the scavenger hunt. You're welcome to breeze through this real quickly. If you think you get it all, you don't have to listen to me talk. There are no videos online per se that necessarily solve these, but if you do any kind of a Google search and you just say, Desmos, or how do I calculate the mean and the median of 10 numbers, it will tell you in a heartbeat. So what I really would like you to do is just go through the activities and play around with them and then Google whatever you need. That's what teachers do. But for those of you who feel as though you should be told exactly how to do each step, stay tuned. Here we go. The first one is I can plot a point in each quadrant and turn on their labels. So one way to plot a point is to simply plot a number. So you make the curly, just the regular brackets, and let's say we want to put 2, 2. Okay. Now you see this label comes up because it knows it's a point. You can click on the label and the default is 2, 2. If you would rather have the label say, I don't know, Janet, then see it'll change to Janet. And the other thing that you can do is you can click and hold this and it gives you a couple of options. You can change it to a circle or an X, or you can change the color, and you can decide whether you want to drag it or not. Okay, so now it's blue and it's draggable in both directions, or you could make it just draggable up and down, or just draggable left and right. So let's just make it draggable in all directions. So there you go. Now you can see that I can put it in all 4 quadrants. Second challenge is to plot a point and adjust the slider settings so the point is restricted to integral coordinates in the first quadrant. So if we click on the solution, let's see here. If we click there, sorry about that. Okay, if we click on the solution, we see you have 2 sliders, A and B, and the point A, B. And what that does is it allows the A coordinate goes from 1 to 10 and the B coordinate goes from 1 to 10. You can just click on this and notice the step is 1. That's how they make it integers. Now let's suppose that I want to make it, so now you see they can go in any direction there, but I can't pull it any lower than that. Another way to do this is you could, even if I have, let's say that I have B for some reason, I want to go from -10 to 10, step 1, okay? Now what's going to happen is it allows the Y coordinate to go down, but it still doesn't allow the X coordinate. So now it'll stay in quadrant 1 here or quadrant 3. Another way you could do this is instead of restricting the B, because for some reason you want it to go negative, you can do this and you can put in these curly brackets, and that says within the B you might want to say B greater than 0. Now what happens, this is kind of cool really, is as I'm moving this down, okay, watch what happens. It still allows me to go below, but it goes away. So B is -3, -2. So the point is there, but you can't see it. So if I bring this back, now we have B again. So we can place our label back there, 3, 4. But as I said, you move it down here, and sometimes you just want it to disappear for various reasons. There's a project I was just working on where that was really handy. All right, so that was number 2. Let's go back to our list here. And what's number 3? Says I can graph a line and a parabola and find their points of intersection. Okay, so one thing you can do is click on the solution and just figure out how they did it. So here is a line and here's a parabola, and then click or tap on the points of intersection to reveal their coordinates. Okay, there you go. There you go. So it shows them up. shows, and then notice here, this is the reason they could put a note here is because you go under the plus key here and you can either add an expression, that's the default, or a note. So if I tried to just add a note right now, right, click or tap, it thinks all those are variables. So that's because they think that it's a function. So what you want to do is you click on the plus and you put in a note. Now I can tell you what to do here. Okay, so that's what that's for. Another really handy one to look at is the folder. The folders are so cool, and they're going to be really important a little bit later on. So let's say, for example, that I want to hide these two notes, or hide them for later, okay? Or hide something else. You can just grab the item and put it in the folder like that. I guess I put a note here. I'll put in here quadratic. Okay, then now I got something else here, but now what you can do is if you hide that, then everything within that quadratic folder gets hidden. You can also click here and that will hide anything that's in the folder. This is going to be really important too. All right, so that would be number 3. So now let's move on to number 4. I can graph a line with sliders for the slope and the y-intercept. So here, what I would like you to do, I'm just going to clear this slide out. And this is one of the ones I want you to do for homework. So if you type y equals mx plus b, it automatically knows, oh, you want sliders for m and b or all. And now you can show how the function moves up and down. Let's make this a little bit more interesting here. Suppose that you want to plot the point where this crosses the y-axis and where it crosses the x-axis. So where does it cross the y-axis? Well, that is when x is 0. Right now it's going to be different depending on the values here for m and b of the y value. But I'm going to change this from y equals mx to f of x, because now notice nothing happens to the graph, but it does show what we can do now is I want to say what is f of 0. Oops. If I type in f of 0, it tells me it's 3.7. Suppose I want to plot that point, so I can just plot the point 0, f of 0. And now you can see that as I move these around, that point stays. You can also label it. It's 0, 3 unless we want to change it to something else. So as you change the values, right, that will change. Let's also label this one. What's happening here is this is when f of x is equal to 0. So in that case, think about it, right? You want to say that f of x is equal to 0, which is equal to mx plus b. So if I solve that for the x, we're going to get negative b is equal to mx, and then x is equal to negative b over m. So I'm going to plot the point negative b divided by m, 0. Ha! It worked! Isn't that so cool? And now I'll call this the y-intercept. Okay? Or another word is the 0. Okay? And so you can see that you can actually play around with these things even though they're variables. So now, notice as I move the variables, the y-intercept, let's make this label something different. Let's make this, say, x-intercept. So using a little bit of math, you can play around with these in such a way as to really be creative with your labeling. Okay, so now that shows the x and the y intercept. Hope that was useful for number 4.